Many physical properties of chemicals, such as boiling point or viscosity, can be determined by knowing their intermolecular attractive forces. Intermolecular means between molecules, so we're talking about an attractive force from one molecule to another molecule. And what's vital is you have to know the shape of the molecule, the three-dimensional shape, to figure out the polarity to understand what types of attractive forces that particular chemical has. The first intermolecular attractive force is called dispersion forces or London dispersion forces. Every chemical has London dispersion forces. For example, diatomic chlorine is a nonpolar molecule. Here are two diatomic chlorines close to each other. London dispersion forces are caused by the random motion of electrons in one molecule can induce a dipole in a close by molecule. So, for example, if the electrons in the red chlorine go towards the bottom of the molecule, that's going to change the electrons in the blue chlorine. Electrons repel other electrons. So the electrons in the blue chlorine will move away from the electrons in the red chlorine. In other words, the top half of the blue molecule is positive, and then we get attractions between the positive and the negative parts of the chlorine. That's the dispersion force, the London force. This is a temporary dipole. We have a temporary negative end and positive end. Because it's temporary, that random motion of electrons is going to cause that dipole not to exist after a certain amount of time, which means this is the weakest intermolecular attractive force. However, we can compare the strength of the dispersion force, and it's proportional to the molar mass of the chemical, because as the molar mass increases, the number of electrons increases, and it makes it easier to get a temporary dipole. That's called the polarizability of the molecule. So, for example, diatomic chlorine exists in the most stable state as a gas. However, iodine, which has also a nonpolar structure, has stronger intermolecular attractive forces. The dispersion forces are strong enough to hold this together as a solid.